Alright, let's try to understand regarding 3D vectors. So let's take an arbitrary 3D vector. So this will be the z-axis, and this will be the y-axis, and this will be our x-axis, right? So after that, what we need is an arbitrary vector, right? So let's denote that vector as A. Okay. Now this A can be written as this. It has three components, X, Y, and C. And here also we need to take a transpose just to write it as a vector. So it literally means this, right? So let's consider how we can get the magnitude of a 3D vector. So as we know, along the z direction we have the unit vector k. Along the x direction we have the unit vector I, and along the y direction we have the unit vector j. So I, j, k are here. Now we are going to find out the magnitude of this vector. So as we know that this vector is composed of three components, right? X, Y, and Z. Just let's first consider these two components, right? X and Y. So it has some X component as well as some Y component. So we can denote that with another symbol, let's say A dash, and this A dash consists of the X and the Y, right? So something like this, right? So what about A dash? A dash, you know that this forms a right angle triangle when we consider any point to the X and Y. So what we can do is apply Pythagoras theorem. A dash is going to be equal to square root of ax squared plus ay squared, because they are the two components along this one. So this is ay and this is ax, right? So we can get the square root of a dash, right? That gives us a dash. But still we have a problem now. Real a is over here. A dash is like the combined magnitude of x and y components, but we still have this one. So this is that. All right. So you know that this is along the xy plane. So definitely, as this point is above the xy plane, this needs to be 90 degrees over here. So if that is 90 degrees, then we know that this component is z, right? Because this is 90. So again, to find the modulus or the magnitude of the vector, of this vector, we have, what is this one? This is a dash and this is a z, right? So we can find the magnitude of this one as a, actually a is equal to square root a dash squared plus, similar to what we did, right? Because this is a right angle triangle, this will be a z square. Alright, so once we have those two settled, we can go on and substitute the rest of the equation. So final result for the modulus will be square root a dash squared, right? So it will be this one, ax squared plus ay squared, and whole thing to the power 2 plus z squared, right? So when we open up the brackets, this will be square root a x squared plus a y squared plus a z squared. That's how we get the magnitude of a 3D vector, right? So the important concept is that this is 90 degrees, so we basically decompose these triangles, right? To get the values, because this is a x and these two, this will be a y. So this resultant will be square root of ax squared plus ay squared. So once we get that, we have a 90-degree triangle again at this point. So we couple that with the az component to get the modulus of a. Yeah, hope you got what I said.